Cool, let's go for it. Okay, so I'm going to talk about a little bit of a... What?
Stall you for a second. Or with it being 9 past anyway.
I'm just here, we don't still on the right.
Normally tokens the...
You have to make them talk about 5 minutes once the Matt's spoken for his introduction.
Well, I'm going to introduce Jono. He needs no introduction, perhaps. 2 things that I have to say. I want everyone to make sure they register. Firstly, I have been told that we're not moving the exam. The school has claimed that it now has an official policy that the exams office decision about scheduling is final. So that's it. Sorry about that. I argued about this, but secondly, more positive thing for you guys. This is essentially the last lecture of the course. I may put on a revision lecture in week 12, depending on what people want, but no more content. So next week, you're just working on your work. I will have my normal consulting times, and if you want to talk to me out of those times, then send an email and we'll set up something. This is all I wanted to say.
Cool, no, it's good. We'll go for it. So I'm going to look at, I'm going to give you a very brief introduction to a thing called ergons, exponential random graph networks, which is one of the statistical ways of looking at networks. So you've probably done a lot of probabilistic ways. There's a couple of statistical ways of looking at networks. I'm just going to give you a very brief introduction to the concept. I'm not going to go into details, it's just a single thing. So I thought, well, what should we look at? So I decided I would look at the Hobbit as an example of a very simple network. So if anyone wants to follow, I will let these HTML be fully available. I'm also, if it works, recording this video, and I'll always put it on YouTube and give you the link. Well, I'll give Matt the link. It's up to him whether he passes it on or not. So if you want to do it at home, here's your usual setup. Hopefully by now you all know about Pacman for your package management in R. If you don't, I highly recommend you go and learn it. It makes everything so much nicer. To recap, the whole idea is that Pacman tries to load the library. If it doesn't have it, it installs it, then it loads it. So if you're using R, it's just a nice way to make sure you've got the stuff. And I've set the theme to black-white. If anyone wants to know how to do these slides as well, go and look up Zarvigan. Zarvigan's the latest theme for making slides in R Markdown. So I went and got the data. So here's the resources I have for the data. So first of all, if you go to the website archive.org, they have a lot of books on there. And I'm afraid I did something as boring as I went to the page that had it and I copy and pasted it into a text file. I also wanted the characters, so I went to Wiki and had a link of Hobbit characters, and I'm really sad I did actually type that up myself directly in a spreadsheet. I feel sort of dirty about it, but this is why I haven't done the Lord of the Rings, because I looked at the Wiki page of the Lord of the Rings and thought, I'm not doing that amount of typing, so I walked away very quickly. And also I wanted the locations. I'll show you why I want the locations in the very final picture of, because unfortunately, like all great academics, I got a little bit obsessed, and you'll see at the final picture what I spent most of my time doing rather than actually writing a talk. So how do I clean the data? Well, first of all, you just read the data in from this text file. And then when I had a look, you can see that there's a lot of stuff at the start, which was just your preface, your information about the book itself. So basically, I searched in there and said, well, where's the first chapter? Which I found here, so I'm using string detect to say, look in the thing, which line has the first chapter, get rid of everything before that. That's all that line's doing. So you can see now, and roughly we've just got, each row of this is a line within the text. So I've just taken that line in the text. I also searched and found the very end. And the very last phrases in The Hobbit is, handed him the tobacco jar. So I found to that point, and we've just searched. And we've got rid of all the sort of stuff at the start and the stuff at the end, and I've just got some text. So there's my data as we see. So you've just got this very long thing where you just have a huge vector of text. And what we've got is each element within that vector is a line. and that's it. So, what I did then is I quickly added a little bit of code. I converted that into a tibble, which is, remember, is a data frame, which is just basically a spreadsheet, where each row is going to be a line. And what do I know about each line? I have the text in that line, and also I quickly added the line number, and I did a quick hack here where I'm searching and saying, does any of the lines start with the word chapter? When it does, just start counting that, and that basically gives me rough chapters. So it starts at 0 and it sees a line that starts with chapters, so that's going to be the first chapter. It puts chapter and everything's 1 from that point onwards, until further on I get another 1 and it adds another 1 to it, so it becomes chapter 2. So it's a very simple structure. Each row is a piece of text, and I know which line it is and which chapter it's from. So this is what it looks like. Here I've got a column which is text, I've got line number, and I've got a chapter. So the next thing I did now is, if you haven't seen this before, there's a really nice package called TinyText, which will let you do natural language processing. A lot of you have seen this before. But generally, all it does is it takes that text and it will convert it into a data frame that's a long form, where each row will be a word, and it will tell you where that word came from. In this case, the line number and the chapter. So you can see that at the start we have, chapter 1, line 1. It says chapter, then we've got 2, etc. It also does some cleaning. Notice everything now is lowercase, and it does some general cleaning for you. And it's called tokenization. It's basically, it can recognize word boundaries, and it's just splitting in word boundaries. You can also do tokenization on 2 words at a time. You can do it on lines if you want. You can do paragraphs. You can do various structures back.
How does it do with hyphenation of words that cross lines?
It has problems. It has real problems. I've written a R package to edit my students' work, who unfortunately most students gone through this, and that actually takes the PDF and it reads the PDF in, and with PDFs, the hyphen, I wrote some code that recognizes the hyphen and joins the words back together. So no, I don't think it deals with it very well. This one, it was fine, there's no hyphenation, but you do find when you're dealing with text from a PDF, yeah, you have problems. So. And this was a quick dirty hack. This wasn't me doing proper coding, this was me being quick and dirty. So yeah, the thing this is doing, and for those that don't recognize, modern R, this is saying take the data frame Hobbit text then, so this migrate R is then a nested tokens where the output will be the word, and the input was the text, and it just does it all automatically. It's beautifully done. I removed stop words. I could have actually removed a lot more words, and you'll see that in a second, but I just, and, if, but, etc. I just did an anti-join to get rid of all the sort of general words. You can see it gets rid of things like the I, etc. So, how we do our social networks, there's different ways we can do it, but every time someone talks about a network, you have to ask the question, what are the nodes, what are the edges? So I decided, first of all, this is where I went and got the characters. Each of my nodes is going to be a character within the Hobbit book. So I had my list of characters. The first one I can go and say, is there a character there? And then I wanted to, initially I sort of said, I will connect 2 characters within the same chapter. But I had a chat with Matt, and Matt actually came up with a much nicer idea. And he said, well, no, you want to get this indication of sort of interaction. So we did as a proxy of that, is if you get a character, and then something happens and then there's another character, we're going to assume that because they're together sequentially in the text, there's some sort of interaction. So that's what I'm doing. I'm going to look at the characters and say, if you are sequential, I will put an edge. I need to take into account chapters, because you could end with, one, like here, you could have Bilbo does something, then it starts chapter 2, and then Gandalf does something. They're not really interacting because you've got a start of a new chapter. So that's what I'm going to do. I'm going to define my edges that way. So here's the one line. We all know about John O's 1 lines of R code. And basically all it does, it takes the text, it first of all just grabs all the rows that is a Hobbit character, and then all it's doing from there is it's counting the next character. It's putting next to it, it's counting them. So all I've done is I've taken the characters, put it again and shifted it 1 up, grouped by chapters, and just went, if this is the next chapter, it's there, it's done.
Give me PTSD from the last message to Simon.
It's beautiful.
I've just done it in a for loop and written it so much quicker and it would have been the same speed.
For loop, cool, which means so much quicker. Matt said, you know what would be better? I walked, the longest thing for this code was walking to my office going, and walking back and went, did it? Yes, it's a lot better, Matt.
What does the lead function do?
It just, anytime you have a column, you have lag and lead. Lead will take that column and put it again, but shift it one up. Lag will shift it one down and just put an NA at the start or the end depending on how the shift goes. Really, really useful when you want to compare sequential rows. So here's what it looks like. So in chapter 1 we have Balin and Bilbo, and they have 2 times that they interact, etc. Okay. So that's my equivalent of an edge list. We've got the chapter, we've got the number of times, etc. How am I going to convert that into a network? So there is quite a few packages. One of the hardest things about networks is every Tom, Dick and Harry went, you know what? I should write myself a network package. And they all went and did it. In fact, if you really want to go through a lot of hardship in your life, you should get together with Matt and write a paper on all the different graph formats. How many did we get in the end, Matt?
100.
There's 100 different graph formats. Because everyone went, I don't like them, 99, I should create myself a new graph format. So, you will find if ever you're doing networks in R, you just have to move between the different networks. If you want to do probabilistic, if you want to do quick algorithms, etc., go and learn the iGraph package. If you want to do social networks, you're going to have to use the Ergon package. If you want to have that tidyverse type manipulation of your network, there's a new one out called TinyGraph. And TinyGraph will let you manipulate networks in a way of going, could you just grab me all the edges that match this? Could you grab me all the nodes that match this, etc. The other nice thing is for small graphs, it's a nice way of visualizing it because there's a thing called gggraph, which gives you ggplot-like facilities to plot networks. So here's me creating my tiny graph. I give it the nodes as a data frame, in this case the characters. I give it the edges, and it's obviously not directed. I'm just going to assume that there's an interaction, it's both directions. And this is what it spits out. It's quite nice when you call it. It gives you the first few nodes. And you can see for each node I have, for my data, I have their full name, a short name, and I have the race, which I got. So I was interested in is, and we'll get to it, is a homophony when it comes to race. With edge data, it basically gives you the edges, and I've got some metadata about the edges, which is the chapter and the number of interactions.
Gandalf's not a wizard. Wizard's not a race. He's a human.
No, he's not a human.
Oh, here we go. You take your time. The thing is, get the punch in first, and then explain to him why he's not a wizard.
He looks like a human. Therefore, he's a human.
Yeah, I look like I'm a human, but we all know I'm not. So, I mean, I'm not using that logic.
You're claiming you look like a human.
No, not like a normal human. Like sort of humanish. Humanoid. We'll go for humanoid. Now I'm not allowed to swear in lectures. I can't fully express the answer that you really need there, Matt. Okay, so let's produce a figure. And as I said, gggraph is nice if you like ggplot2. If you don't like ggplot2, you're an idiot. There you are. So you basically use the gggraph object for your network. I'm going to add some edges. I'm going to add some nodes. And I said I would like the color of my nodes to be based on race. And give me a legend for that, please. I would like the nodes to be size 5. And I'd like a label on that. Set theme graph and legend position equals bottom. And here's my network. Now, the thing about network visualization is, to some extent, it's absolutely useless. It's the best eye candy we've ever produced in mathematics that is completely useless. Everyone loves it, they love it. Nature has a compulsory thing now that once a week they have to on the front cover a picture of a big network. Here's the internet. Here's the network of a neural system. And it never tells you anything. It never really tells you. It's only when it's small you occasionally see patterns. And I think this is a classic example of it looks pretty, it looks nice, but it doesn't really tell me anything, unfortunately.
It tells you galleons a bit useless.
Yep.
That's about it.
That's about it. That's about it. So then I started to think about questions about what we could ask of this. So I added first of all so I wanted to ask the first question, which is which character is most central? So we're going to add some centrality measures, and this is how you do it. Let me work through this. So we take our network, then we activate the nodes. The way TinyGraph works is you've got your nodes and your edges. So depending on what you want to work on, you just let it know. So you say, activate the node says, I'm going to work on nodes. So we've got a mutate command. I'm going to say to each node, add me a column for degree, which will be your centrality degree, a column for your betweenness, a column for your closeness, and a column for your eigenvalue centrality. So we've got these, I mean, there's lots more measures of centrality, but here's the quick form. Once I've done that, we can plot it. So, what do you notice? Does it pass the stupidity test?
Yes.
I agree, I totally agree. And in undergraduate, I would be so impressed that students are talking back to me. But now you're beyond undergraduate, I'm going to ask that horrible question, one of the classic 5, why?
Because Bilbo is ultra popular and Galleon, the useless guy, just no one cares about it.
Yeah. What do you notice? I mean, that's a really good answer. What do you notice between Bilbo and Thorin?
A different order of their centralities.
That's really interesting. Well, I thought it was interesting. If you look at Bilbo, you're right, he knocks out the park when it comes to centrality, but mainly about betweenness. He's a central character because a lot of people are joined to one another through Bilbo. They talk to Bilbo, and someone else talks to Bilbo, and hence you get this connection between them. Well, Thorin is going and talking to everyone. Thorin, it splits over, and now with Thorin, it's the purple one, it's the eigen, or even more interesting, the degree and the closeness. In fact, he's not a very between character. He's not sort of actuating conversations or interactions between people. He's interacting with lots of people, which is interesting. The rest sort of follows through. It was a pretty plot, and it came out quite nicely from that very simple TinyGraph. So let's think about homophily. So, I assume you've defined homophily, but let's recap it. Homophily means you're more likely to get an edge between two nodes if they are the same under some sort of factor. So in this case, we'll say you're more likely to get an edge if it's between two nodes of the same race.
So how racist they are.
That's what we're going to get to. So we're going to start, we're going to this time activate edges, and I'm going to grab, for each edge, I'm going to say, can you tell me, with the edge, what's the race it's from? What's the race it's to? What's the name it's from? What's the name it's to? And we'll classify homophily is basically if the from race is equal to the to race. That's quickly how we do it. And now I'm going to take that and I'm going to create myself a graph. I'm going to add some edges that are going to have a colour based on whether homophily or heterophily. That's probably the wrong word, but not that I've ever started saying words correctly before. We've got the node label as before, with some nice colours, the graph, and I'm going to facet it on that homophily. So very like ggplot2, if you've done that before. Ooh. So here we are. They are all the edges that are heterophilic edges, and these are all the edges that are homophilic edges. What do you reckon?
Dwarves are racist.
Dwarfs are racist.
The trolls form a clique.
Yep. Is that what you expect?
Yep.
Yep.
Because no one likes them.
And also they appear in one chapter, and they basically become garden ornaments at the end of the chapter. Sorry to spoil, I should have broken that to you. He gets home again, by the way.
Also the trolls.
Yeah. That's called there, and it's not just called there.
Be great, I'd read that.
Yeah, just there. And then, like his nephew, he gets to keep his. Okay, spoilers. So we definitely, and we've definitely got the trolls here forming a clique. The dwarves really are just chatting to one another. Okay, these are not really chatting to any of their similar thing, but that's because Smaug doesn't have a lot of dragons, hence his grumpiness, his tetchiness, he's sad, he's lonely, he's only got gold to keep him happy.
Is it
What?
that, like the only two elves in the whole book never interacted with each other?
There are 3 elves in the book.
I did filter a little bit.
Okay.
There might be more characters than I put in there. According to this, yes. Now, it might be that my code is wrong and I need to go and check.
Got it.
But it might not be that they ever interact with one another. So, let's ask the question that everyone was thinking, are dwarves racist? So what I've done here is I've just counted and said, let's have a look. We're going to look at all the edges that are from a dwarf to a dwarf, one or the other. I'm going to count how many of them are homophily. So we talk about every edge that involves a dwarf, and we say, is that dwarf talking to someone else or not? And we find that generally, okay, 54% of the time they go and talk to someone who's not a dwarf, but let's face it, 45% of these times, these dwarfs will only talk to another dwarf. So, are they racist?
Because they define races.
Good question. What do you mean by racism? Well, I mean, not generally, but what do you mean by racism in terms of homophily? Why do you think dwarfs are talking to dwarfs?
Because they go on the adventure together.
There's that, but why else are dwarfs talking to dwarfs?
They live near each other. Like they live around the same area.
What else do you notice about that?
There's a shitload of them.
There's a shitload of, I'm sorry, I can't say, there's a large number of dwarfs. there's a lot. It's leading me into trouble again. If you were randomly a dwarf and you went to choose randomly another node to have a chat with, are you more or less likely to talk to another dwarf?
More likely.
Yeah. You know, they're all dwarfs. You might hate dwarfs. I never want a conversation with dwarfs. I'm going to, oh, you're all dwarfs. Hello, how are you this morning? So I did that test. I actually counted and looked at how many of each one and did a prop test. I said, given the amount we did and given you're randomly choosing them, what's the probability that you would get homophily? And as you can see, it's just a one sample t-test. No, there's not a significant, to be a proper homophily in this case, and there's a good lesson here, you've got to stop and think about your data and go, are they talking to dwarfs because they're racist, or talking to dwarfs because there's no one else to talk to? And in this case, there's no one else to talk to. So, let's start modeling this. We've had a bit of a play, we've visualized, standard stats, get your data, clean your data, have a look, start thinking about some interesting questions. Now let's start thinking about our model. So, we're going to do an exponential random graph model. So, basically, all an exponential random graph does is it fits a logistic regression. So remember, logistic regression, you have a response variable that has 2 possible states, success or failure. And we're normally trying to predict the probability of success. What do an exponential random graph? We're going to treat each edge as a Bernoulli random variable. And the Bernoulli random variable, we want to work out the probability of it being there. But we're going to change that logistic regression slightly, because the biggest assumption of logistic regression is all your observations are independent. But you often don't get that in social graph networks. You get a thing called, for example, transitivity. And transitivity says, if you have 3 points, and the first 2 points have an edge, you're more likely that the last one has an edge. So the probability of an individual edge will depend on the other edges that are around it. Yeah? So this is the general form. We're saying the probability that are y of all the possible edges. So we're going to look at all possible edges. I'm going to classify them as 0, 1, whether they're there or not. So there's going to be, think about it, 2 to the n choose 2 possible edges. We're going to take all them edges and we're going to treat them as a Bernoulli random variable. We're going to observe them. And we say that this is, you've got your 1 over your kappa. Your kappa is just a normalization constant, so you can ignore that. That's just to make sure it becomes a probability mass function. It's an exponential. We're going to have parameters theta, and we're going to multiply them by this GHY. GHY is what we call a config. And all we mean by a config is, for example, Your simplest config could be you could just count the number of edges. You could also have a config where you take 3 edges at a time, and you basically, if you look at this, say, we're going to say that this config is 1 if you had all 3 edges and 0 for anything else. So you're counting triangles. Which is why the biggest criticism you ever get about ergoms is someone who's a probabilistic person, like Matt, will just go, it's just counting triangles, isn't it? And yes, he's right. So what you're going to do is you're going to go to each edge, and you're going to count all the configs and look at the change in your config structure if that was an edge in there or not. So it's got 2 things. One, you only care about configs. And how you choose what configs to do is to do with what we call the Clifford-Hammersley theorem, which I'm not going to go into. But the other thing you're going to do is you're going to regress your logistic regression back on all the other observations, which we normally don't do. Normally, we treat each logistic regression binary on its own. This one, we're regressing them back on themselves. Okay? To give you an idea, the Bernoulli random graph, which is the Erdos-Gilbert-Rennie, in that case, all you're really doing, your config is Ly, which is you're just counting the total number of edges. A Markov graph. A Markov graph is a dependency structure where you say that 2 edges are independent unless they share a node. You can show from the Clifford-Hammersley theorem that if you care about that as your dependency structure, that 2 edges are independent unless they share a node. Only thing you need to worry about are edges, the number of k-stars. So a k-star is basically, you have a node and you have k edges coming off it, and the number of triangles. So you've got this idea you can just regress on itself. What about node attributes? Well, now we can add extra configs in there with basically a weighting term. So for example, I could add in terms of the form gx is yij, hxi, xj, where xi and xj will be attributes about my nodes. So you could do simple things like you could, have main effects. Maybe you want to have the probability of an edge dependent on a single, categorical or quantitative random variable for each of the 2 nodes. Maybe you would say you're more likely to have an edge between our 2 characters in the Hobbit, depending on the age. So you could add the ages of both nodes and work out the probability of an edge. Homophony is as simple as going, we'll have an indicator function. If you're of the same type, you get an extra term in there. If not, you don't. Ergom has it, and they have various things. You can have categorical node effects with node factor. You can have continuous node effects with node cov. You can have homophony with node match. And we'll see how you do it in a second. There's a book on Harris that has the idea that the way they start is the null model. They start with an Erdos-Rennie Gilbert, and then they slowly build up adding stuff in. So they normally start with just a number of edges. That's your null model. Then they'll say, right, now do we have to take into account node factors? Then we'll add in homophily, and then finally the more advanced dependency structure, because it turns out to be like interaction terms equivalent, is we go, do we have transitivity? And you build up this structure. It's a very sort of statistical approach. Start with a simple model, build up. So here's how you do it. So again, you can use that structure we had before. I've got my Hobbit net. The first one I'm going to fit an ergom, and I'm just going to fit a Gilbert Erdos-Rennie and say, start with my null model with the number of edges. The next one I thought is, well, maybe certain races have more edges associated with them. So the next thing is I added in a predictor, which is a categorical variable, hence node factor, that depends on the race. So it's saying, is there an increased likelihood of an edge if a node is a different race? So I'm looking at race structure. And then finally, I also add in a homophily type thing, node match for race as well. And I just use an AIC to compare them. So you can see that all together, remember we want, I can never remember this, the smaller AIC. So basically we found that 2 was most likely in this one. So the nice thing is we're saying that yes, you got a Gilbert Erdos-Rennie, but that's not the lowest.
3.
Is it 3? I went for 2, I think. Did it? No, I went for 3. No, I did go for 3. Woohoo! So we know that we need a term for the number of edges. That's your normal model. You had that anyway. Yes, the race has an effect on degree, and not just that. If the races match, even though we didn't find homophony with the dwarfs, there is homophony here. We find that if 2 nodes are of the same race, that's more likely to have. Let's check. It is more likely. Yes, if you look at the estimate on race. So here's your output, your summary table. So this will give you your estimate of your probability of an edge. Then you've got how much you increase for the different things. They're all being compared with the reference level, which I can't remember off the top of my head. I can't remember which one's the reference level. Maybe it comes alphabetically, I assume. Can't remember. So this is the extra amount you would add in probability in a probability space, so it's in a logit space, to get an edge depending on the different races. And you would add these 2 things for each of the nodes. And then finally you have this extra amount you add if they're of the same race.
Would the dragon be the reference case? Smaug? Smaug?
Yep, thank you. Smaug.
I don't want to start something on that.
Well, you've already started with that he's not a wizard, so I think the dragon thing's like slightly irrelevant now.
It's so easy to roll you guys off.
Any second now, you're just going to go, yeah, it was useless, I was a Harry Potter fan. And at least one person is just going to rip your arms off. So you can use this as a predictive model. You can ask a simple question if if I came along and said, here's my 2 nodes, one's a dwarf, one's a dragon, you can now work out the prediction that there will be an edge between them. You can also use it to simulate models, etc. So the standard sort of stuff that you'd want to do.
I think the best part of this is that it has the stars.
Yes, it has the stars.
So when that puts it in the exam, it's going to be okay.
No, I know how to remove stars for the exam. Lucky for you, I'm not writing your exam. And then finally, this is what I spent all my time doing. So this is the Hobbit. This is my network. This is what I spent. The rest of the talk was like 20 minutes. And then I went, it'd be really good. It'd be really nice if we could draw a picture of the Hobbit. So let me break down what my picture is so you can see. So first of all, as you go across, these are the chapters of the book. Yep. Then this is the location of the chapters. So as you can see, and the green line is Bilbo. So you can see Bilbo moving along. He's not in this chapter, and it moves, and then it goes along. And I did that, and I went, well, you need more than that, don't you? So the next thing I did is I went, well, let's see who he's talking to. So this is Bilbo and who he's talking to. They're coloured. I spent 2 hours deciding on colours. They are coloured by which race they are. So obviously this is fire red for a dragon. This is actually a gold for dwarfs. The elf is something like sky blue. Now the colours for the hobbits, then the obsession had kicked in properly now. So I went and found a picture of the old version of the Hobbit online. I then went and grabbed some of the colours from the front cover. This background is a colour, this green is a colour. This font is a special Hobbit font I managed to find. It's still going though. You think he's stopped now. No, he went even further. So we've got who he's talking to, Bilbo, as he goes through the book for each of these. Then I thought, what's he talking about? If you look in the background, first one in the background, there's actually very faintly the map of the Hobbit. But if you zoom in, this is a TF-IDF. This is, I've looked at the key words that are frequent in each chapter and compared them with the other chapters so you can see what he's talking about. So here he talks about things like map, finder, Gandalf. We get to this point, guess who appears in this, that one of the keywords is precious? It's Gollum, yes. All the way to the end, we talk about joyful, etc. And finally, because once you start an obsession, you should finish it off, I put a picture of Smaug. That picture of Smaug is actually someone's tattoo I found on the internet. So I actually took that, I then stripped it out, made it transparent, and put it on to give you a picture of the Hobbit. And with that scary obsession, as you slowly try and escape from the room, I will call it quits and say thank you very much.
And you did all that in one night.
If anyone wants a copy of this picture, you're very, very welcome. I also wrote up my obsession as a blog, and rather than publish it, Matt just got me help.
We're going to publish it. We've got.
It'll go up. Is the question just again, why?
No, it was going to be more, do you think you have too much free time on you? Because academics work hard, I acknowledge that. But usually on, I don't want to say important things.
This isn't important. You have to think in terms of permaculture. So permaculture, I know it doesn't make sense, but let me explain. Permaculture is this idea in agriculture that when you develop gardens, etc., everything has more than one use. So this is a complete obsession by me because I wanted to make something that in my mind was pretty and fun. But to do this is all done in ggplot2. I learned how to take other pictures and make them transparent and get them on a picture, which is a useful skill. I learned how to do TF-IDF and identify keywords in a text, which is a useful skill. I learned how to embed fonts that are not the standard, which is hard to do in GG. It's hard to do generally, but to embed fonts is really, really important and a useful skill. I also learned how you can take a picture and identify the colors as RGB and then embed them and create your own palette. So yes, it's a waste of time, but there's basically 5 skills that I learned for plotting that will be really useful for the next time I have to do a real plot that's something useful.
I'd also argue that, you know, the analysis of stories and narratives is actually a really interesting facet of human behavior because we mirror a lot of what we think about the world in these stories. So, you know, for instance, Tolkien was involved in one of the world wars. I forget which one, World War II?
World War I.
And that shaped a lot of his narratives. And so in some ways, these stories mirror aspects of the world he was living in. And the network analysis, I mean, there's some obvious themes in those stories, particularly The Lord of the Rings, which match up with World War I or World War II. They're just those horrible scenes in Mordor and so on. But what you're seeing here is a more subtle thing about the way he saw English society and the way people interacted in English society. And that, I think, can be a really interesting thing to study more generally. So I don't think you should trivialize the study of stories, particularly not stories which have been so resonant with so many people.
Yeah.
Some interesting chapters here. The 5th one, which is just Gollum and Bilbo. I can't read the title of it from here.
The 5th one, Riddles in the Dark.
Is that the one when they're in the cave together?
Yeah. Yeah.
Also, there's a chapter without Bilbo in it.
Yeah, no, it goes away. This one, which is Fire and Water, is where Smaug gets killed. Yeah.
Because all the dwarves.
Yeah, and in fact, if you look at that one, Fire and Water, you get here, you get Lake. Actually, no, he might be over here. He gets killed because there's one where you definitely, as you zoom in, you get Boat, you get Bard, you get Arrow, etc. The TF-IDF worked quite well actually on this one. Some of the words that came up did sort of match the key themes for that chapter.
I love the effort of the font. It is a touch hard to read.
Yeah, it's a zoom-in picture. I actually made this really, I tried to send it to Matt and it's such a big, because I did it in PNG, because getting the font embedded in as a PDF is hard. But when you zoom in, you can start exploring it and it actually works quite well. And I did it such that you can actually see the fonts once you zoom in, because I want to make this as a poster to go in my room.
Understandably.
Find out.
By the way, technically Gandalf is in Istari.
Oh god. Great, there's a nerd battle.
Yeah, wizards are job, not a species.
So you're saying Jonah's not a mathematician?
Oh, we knew that. Yeah. If you spend your whole time just doing pretty pictures.
He's not, really.
Yeah. I used the classification that was given on Wiki. Not that Wiki would ever be wrong. Any questions?
Jono again.
Thank you very much.
So I have a thank you thing back in my office.
Yeah, cool. Thank you. I hope that did record.
So any last questions about organisation?